The next thing we're going to learn about is the gas laws. There are 3 of them, and the first one is called Boyle's law. Now, we are the gas particles and we're inside a box. Just a regular box, but we're a very, very special gas. We're called an ideal gas. Whee! Listen, boys, we're an ideal gas. Way! But what does that mean? Well, because we're an ideal gas, that means we have to follow special rules. The first rule of Ideal Gas Club is there are lots and lots and lots of particles. The second rule of Gas Club is that when we're bouncing off each other, these collisions are perfectly elastic. Can you remember what that means? It means that there's no energy lost in the collision. The third rule of Gas Club is that when we're bouncing around, the only time we interact with each other is when we hit off each other. There are no forces between us. And the last thing about us, the last law of Gas Club, is that we're very, very small. That means that the box is mostly filled with space. So that's the rules for being in an ideal gas. Whee! Now, the first gas law we're going to learn about is Boyle's law, or as the French call it, le Mariotte law, or something like that. Boyle's law concerns the gas particles in a box, and I want you to think about us bouncing off the walls and bouncing off each other, but we're going to change something, okay? We're going to change the volume of the container. The temperature is not going to change. That's absolutely certain. The temperature is not going to change. We're going to keep it the same. But we're going to change the volume. Now, you can see it's bouncing around. What do you think will happen if the volume of this container is cut in half? Have a guess. If you guessed that when they cut the volume of the container in half, that the number of collisions doubled, you'd be right. Whee! That's what happens. Look, regular size container, we're bouncing off like this. B, ooh, E, ah. But when you cut the container in 2, look, ooh, E, ooh, E, ooh. It's such a laugh. So as you can see, the pressure and the volume are inversely proportional to each other. When you double one, the other one halves.